Weather has played a pivotal role in many significant events in American history, some of them disastrous. One such incident 25 years ago this week vividly sticks with me, an event that shattered the stability of the manned U.S. space shuttle program. The first orbital flight of the space shuttle took place in April 1981, when Shuttle Columbia spent a little more than 2 days in orbit. By mid-January of 1986, another 23 missions had flown using Columbia and 3 other shuttles: Atlantis, Challenger, and Discovery. Weather had delayed many launches and landings during those years, but there were no catastrophic weather-related problems. But one pesky design issue had dogged many of those early launches. To provide thrust, the shuttle uses 2 solid rocket boosters that are connected to a large external fuel tank. Each booster has 6 sections, and some of the joints between sections are sealed by pairs of synthetic rubber gaskets called O-rings that help contain the hot, high-pressure gases produced when the fuel is burned. Now, these O-rings had leaked during 15 shuttle flights prior to January 1986, despite redesign efforts to address the problem. In addition, low temperatures made the rubber O-rings less elastic and thus less likely to properly seal the joints. Now, the 10th flight of Shuttle Challenger was originally set for January 22, 1986. It was the highly publicized first teacher in space mission, but the launch was delayed until the 28th. That morning was unusually cold, with temperatures in the low 20s at Cape Canaveral. Shuttle launches are prohibited at temperatures below 31, so the launch was pushed back to late morning to allow temperatures to warm. But the unusual chill had already compromised the O-rings on one of the rocket boosters. Analysis of images after the accident showed gray smoke leaking from the booster in the seconds after ignition. Now, at first, the damaged joint was temporarily sealed by residue from some of the burned fuel. But about 30 seconds after launch, the shuttle entered a zone of large vertical wind shear, with winds increasing from around 70 miles per hour at 20,000 feet to more than 140 miles per hour at 45,000 feet. And in response, the automated steering system made more adjustments than on any previous flight to counter the changing aerodynamic forces on the vehicle. Were it not for this extra maneuvering, the temporary seal of the booster joint might have held, but instead hot gas began to leak again, and eventually flames that burned through the strut, connecting the booster to the external fuel tank. That started a series of catastrophic events that led to the breakup of the orbiter 73 seconds into flight and the loss of the crew of 7. The Challenger disaster resulted in a 32-month hiatus in the shuttle program, and since then, more than 100 other shuttle missions have flown, with one other non-weather-related catastrophic failure, Columbia in 2003. The shuttle program is scheduled to end this year, the last mission tentatively set for June. Paul is back with the extended forecast next.